Hi, it's homework time. In this video, I'm going to introduce you to 4 new molecules which you've not met before. All of these molecules are made up only of carbon atoms, but in each case, in comparison to the other molecules, the carbon atoms are arranged differently. They're arranged in different ways relative to the other carbon atoms, and they have different sorts of bonds to the other carbon atoms. I would like you to do the following. For each of the molecules which I show you, I would like you to write a very short paragraph in which I'd like you to write about all the ways you can think of for why the structure of the molecule determines the properties which it has. Good luck. This follows on from the lesson we did today, in which we were thinking about the structure and properties of polymers and about smart alloys. So on with the fun. Take a look at this. This is graphite. Graphite is constructed of sheets, very, very thin sheets of carbon, which can slide over each other pretty easily. The properties which graphite as a material has is that it's very strong and very, very, very slippery. It's the compound which is used as the black bit inside your pencil, and it's so slippery that you can drag your pencil over a sheet of paper, and sheets of this graphite come off onto the paper. How do you think the structure of graphite determines the fact that it has these properties? Okay, second molecule, diamond. Do you know about diamonds? Diamonds are actually made up only of carbon atoms. The carbon atoms are arranged in this enormous three-dimensional lattice, in which there's an enormous density of bonds between carbon atoms. Each carbon atom forms 4 strong bonds to the carbon atoms around it. In graphite, there are only 3 bonds, but in carbon there are 4. Well, the main property of diamonds, is that it's extremely strong. How on earth might the structure of diamond determine its most important property? Third form of diamond is this, Buckminster fullerene. Yes, it exists. It's a big ball of carbon atoms. There are 60 of them to be precise. Take a look at it. Isn't it cool? Buckminster fullerene can be used as a great lubricant. Lubricants are used to make things slide over each other relatively easily. For example, if you own a bike, you lubricate the chain so the chain doesn't squeak. Buckminster fullerene is really good for that sort of thing. I wonder why its structure determines that fact. So here's the 4th form of carbon I'm going to show you. It's called the carbon nanotube. It's an enormously long, enormously thin tube of carbon atoms, all joined together by 3 bonds between them. There's quite a high density of bonds in carbon nanotubes as well. Well, the properties of carbon nanotubes is that they're both flexible and extremely strong. I wonder why the structure of the carbon nanotube determines these properties. Good luck. Any problems, come and see me in S8 at 3:30. Spend no longer than 30 minutes on this homework.